Hello students, how are you all? Hope you are all in good health and at home. So stay home and stay safe, all of you. Let's start with today's lecture on chapter motion. We are going to start chapter motion today. As I told you to read few pages of your NCERT book. So today and now in this lecture I am going to discuss only those 2 pages. That is one complete topic. So it starts with motion. What is motion? And what is the other term related to motion, that is rest, and a term which is reference point or origin, we can say, and how these 2 terms, motion and rest, are related to each other, that we are going to discuss first of all, right? So what is motion? Motion is nothing but we will say that any object which is moving, that has motion, right? So how can we define scientifically or physically or according to physics, how can we define this term? This term can be defined as I have written here over here: any object which is said to be in motion if it changes its position with respect to time and surroundings. Now what does it mean with respect to time and surroundings specifically? Any object which is changing its position. Position means that you all know where it is placed. Suppose an object I'm having is a scale. Suppose this is a scale and this scale is placed over here, right? And I'm changing its position within 1 second. I'm changing its position to this position, this place. From this place to this place it has moved because I have moved it, right? So that means during this time when it is changing its position, it was in motion, right? So any object, this is object which is said to be in motion if it changes its position with respect to time. So with respect to time also we can see, and with respect to surroundings also we can see. With respect to time means as the time is elapsed, okay, within 1 second or within 2 seconds or within 1 minute, that we can consider. As time is elapsing, the object is changing its position. And also according to surroundings. Surroundings means the environment. According to the environment, we can say this object is placed in an environment where it is placed on a booklet or on a board. So according to this environment, according to this board is at rest and the scale is also at rest. So if I'm changing the position of the scale only, then it will be moving with respect to this board. Suppose this board is also moving, then is the scale moving? Yes, the scale is also moving along with the board, that we will see, right? So next comes, what do you mean by the term rest? It is just defined in a similar manner as we have defined the term motion. Any object is said to be at rest if it does not changes its position with respect to time and surroundings. It does not changes. Here it changes its position. When the object is changing its position with respect to time and surrounding, it is said to be in motion. When object does not changes its position with respect to time and surroundings, then it is considered to be at rest, right? That means it is stationary. Stationary means रुकी हुई object, right? So these are the 2 terms that we need to understand according to science or according to the bookish language, how we will explain these 2 terms or how we will define these 2 terms. Now these 2 terms are related to each other. And to explain the relation between these two terms, we have to understand some term which is very important term. It is reference point or origin. Origin means where we have to start, from where we are starting. So starting from, for what? Starting for the motion, right? So if any object is moving, it has to be considered that it must have started from any position, right? From any position it must have started. For example, if we are moving in a car, so car must have started from its some point. At some point of time it was at rest, maybe in some parking, or maybe at our home, inside our home it is parked, right? So from parking place, it for the case of parking place, if I consider the car was at rest, and when it is moving, then it is in motion. So from where did the car started? Where? It started from a origin point, a starting point, a reference point. So that is the considered as that point. So what is that point? It is a fixed point which is used to specify the position of an object. Position of an object was the parking place in that example that I was giving you. And it is, if it is changing its position from the parking place to some other place in the market or at somebody's home, so it means it was moving, it was in motion. So there must be some origin point, there must be some reference point, right? If I consider any object to be in motion, or if I describe any object to be in motion, we must describe some origin point. There must be some origin point, right? So how we will define the reference point or origin? It is a fixed point which is used to specify the position of any object, right? So these two terms I'm considering, and only we are considering now that these two terms are relative. How they can be relative now? We have understood just now origin or a reference point, from where our motion starts or from where our object starts moving. This is the point from where our object starts moving, right? If this point is also moving along with the object, suppose, then what we will consider? We will consider that the object is at rest. How? Now this can be understood, this concept can be understood with the help of an example, a very simple example. What is an example I'm taking? I'm taking an example of the same car, right? Suppose I'm sitting in a car and you are also sitting in that car. Okay, if I'm sitting, I will look towards you and I will look toward the other things in the car, suppose, then I will say that you are at rest because you are sitting beside me and somebody else is also sitting. So you are at rest, you are not moving, you are sitting just, right? So I will say, if anybody asks me that whether you are at rest or not, so I will say this person or this student is at rest because he is sitting, he is not moving, right? But the car is moving, right? We are sitting in a moving car. The car is, if the car is moving, then the reference point, then the reference point is also moving, because what is the reference point from where I am looking towards you? That is, for considering the object is in motion or rest, that is me, from my point of view, right? So in that case I will consider that the object is at rest. But if I get down from the car, okay, and now I am standing at the roadside, or somebody else who is standing, suppose consider somebody else who is standing outside on a roadside, okay, outside the car on a roadside, and a person who is standing at the roadside, what he will tell you? about the motion of any object which is inside the car. What he will tell you? He will say that the car is moving and any object or any person who is sitting, suppose 3 persons are sitting, all 3 persons are in motion because the car is in motion and they are moving with the same speed, the speed of the car. Suppose car is moving at 50 km per hour speed, then those 3 persons are also moving with the same speed. Okay, so according to the person who is standing outside at the road, the person sitting inside is in motion. But according to the person sitting inside the car, who is also moving along with the car, the person sitting inside the cars are all at rest, right? So in one case the same thing is at rest, in another case we are saying the same, for the same thing it is in motion. So it is nothing but the concept of relativity, because they both are relative terms. That is why we can say that, right? In this concept I have written this according to that only. The location of any object can be described by specifying a reference point, and if this reference point is also moving along with the object, then the object is considered to be at rest. And if the reference point is not moving, it is at rest, then the object is considered to be in motion. So it is only the concept of reference point from where we are taking the reference point. Either a reference point can be considered as moving, or reference point can be considered as stationary. So when it is considered as moving, when the reference point is considered as moving reference point, the objects can be considered at rest. But when the reference point is considered as stationary, the objects can be considered as in motion, right? So it is the concept of only reference point that we need to understand. This is how we can understand. I will give you one more example which is very very important according to questions point of view also, that when we all are living on earth, and what is the position of earth? Is it stationary or is it moving? It is moving, right? It is taking revolutions and it is rotating also. Okay, so it is 24/7 the earth is moving, right? So it is in motion. But whenever we are considering any object on this earth, on the surface of earth, suppose this object, suppose this pen, or any building or any tree along roadside, these all objects can be considered to be at rest. This pen is not moving, we will say it is at rest. How can I say it is at rest? The earth is moving, and along with the earth this pen is also moving, so it should be in motion. But what is my reference point? I am looking from the surface of earth only. I am sitting over here. Okay, so the point of view or the reference point is also moving along with the earth, right? From earth, on the surface of earth, the observer is here on the surface of earth, and the object which is being observed is also on the surface of earth. So according to that, we will consider that this object is at rest. But if any person which is not on earth, or we can say outside earth, from outside of the earth, if I consider the reference point outside the earth, say on moon, if I go on moon and from there I am looking towards any object on the earth, then I will say that object is in moving. I am looking, suppose, on this pen. Then I will say that pen is moving. From where I am looking? I am looking from outside the earth. Okay, so in that case, it was in motion, and in this case, when I am on the surface of earth, it is at rest. So it is both ways. The object is same, the position is same, okay, but the reference point is changing. The reference point is moving in one case when I am on earth, and the reference point is stationary when I am looking from the outside the earth. Right? So this is how we can relate both these terms. This is very important to understand the concept. Right? Next comes our topic, that is motion along a straight line. Straight line, all of you know, right? In any straight line, if an object is moving, then it is called a rectilinear motion. So rectilinear motion, we all have studied in our previous classes, right? Till class 8 we have studied different types of motion: circular motion, random motion, rectilinear motion. All different types of motion we have studied, right? In this chapter we are focusing only on motion in a straight line, right? And we will understand the various details of this type of motion. First of all, the concept which is given in your NCERT book is the concept of distance and displacement, that is to be understood according to this example they have taken. I am taking the similar example according to your book. This is suppose an origin point, and this is your finishing line, suppose. Okay, so this is a straight line. Any object which starts from origin or the reference point, then it moves in a straight line, suppose, right? So it moves towards A, then it goes towards B, then it goes towards C, and then it goes to D, point D, right? Then what is the distance covered if it goes till D? That you will say. Let's say the distance covered is 50 meters. So what is that? The distance, I'm writing over here, distance. All of you know what is the distance, right? Concept of distance and displacement can be understood with the help of this. The distance covered from O to D is, I will write 50 meter, right? If any object moves from O to B, then the distance covered is 25 meter. If any object goes from O to D, suppose, and then again it turns around and comes back, then what will happen? If it comes back till point B, then the distance will be added. This is 50 meter plus 25 meter. It must be added, right? This, you know, this is very small little thing. With the help of common sense we can understand that. So what is the distance in that case? It will be 50 meter plus what? Plus 25 meter, right? So OD plus, I will write DB, because according to direction I am writing just for the sake of confusion will not be created, so it will be 50 plus 25, that is equal to 75 meters. The distance is this, right? Okay, so what about the displacement? What about the displacement? What is displacement? First of all, I should understand. Displacement of, as this name is suggesting, we will say place and displace. Any object which is displaced from its position, right? So displacement, if it is moving, the object is moving, then displacement must be there, right? The object is changing the position. So displacement is defined as nothing but a shortest distance between the initial position of an object and the final position of an object, right? It is a shortest distance between initial position of an object and the final position of an object. So what is the initial position that we are considering? Initial position is, suppose, this. In the same case, when the object was moving from here and then from here to here. Okay, in the first case, the object was moving from O to D. O to D I was considering. Okay, I could consider from O to B also. It is your wish. I am considering O to D. So O to D, what is the distance covered? 50 meter, that we have understood. So what is the displacement? We should know the initial and final points for describing or explaining the displacement. Displacement is the shortest distance between initial and final points. Initial point is this and final point is this in the first case. So initial and final point, what is the distance? Shortest distance. Shortest distance is always, mind you, it is a straight line distance. Okay, so in the case of displacement, we will write here displacement is also 50 meter. It is a straight line distance. Shortest distance is always straight line distance. Okay, now in second case, the object has turned and came back towards B, right? So what is the shortest distance over here? The initial point was this, final point is going from this to this. This is the final position. Initial position and final position. What is the shortest distance? This is the shortest distance, a straight line distance between O and B, right? So here displacement will be OB, and that will be your 25 meters. Okay, so there is a difference between distance and displacement, but they are equal here, right? When they are equal? When it is a straight line path. When the distance is not a straight line path, it has turned around, there was a curve over here and it is turning, then it is greater than the displacement, right? Now one more case we can consider. When the object is moving here and here, and after that it is coming back to O. What will happen when it come back to O? What will happen? Distance is OD plus DB, and then again from B it is coming back to O, yani ki BO. So what is the distance covered? This is 50 plus 25 plus 25, that is 100 meters. This is the distance. And what is the displacement in this case? In this case, the displacement, pay attention, it is 0. How? Because initial point is this, the object is moving till here and then it has moved till here, then again it has moved to this. Now what is the initial position? This. What is the now final position? This only. Because initial and final positions are same, that means object has come back to its initial position, its initial point, its starting point. Then it means its displacement is nothing. It means its displacement is 0. That means it has not been displaced. It is having the same position, coming back again to same point. So in this case, the object is having O at position O, OD plus this plus this. So we can write in that case OD minus BD minus BO, that is equal to 50 minus 25 becomes 0 meters. We can represent it like this. Here also we can represent it like this. Iski representation I will write down. This case can be written as OD, then it has came back it is minus dB, right? So that is equal to OB. Okay, so it is 50 minus 25. Okay, that also I will write 50 minus 25, right? So this is the concept of distance and displacement that we can understand with the help of motion in a straight line. That is also given in your NCERT book. Some figures can be different, but the concept is like this. Okay, now based on this we can specify what is the difference between distance and displacement. It is very important question according to the examination point of view. What is the difference? I will write difference between distance and displacement. I'll tell you now, distance and displacement, that I will write also, and I will explain side by side what is the difference. So here I will write down the points considered for distance, and here I will write points considered for displacement. In this case we can write down the definition also. The first point difference is definition. By definition we can differentiate also. Distance, what is distance? It is nothing but a path traveled, covered by an object when it is in motion. It is nothing but, it is path covered by any moving object. Okay, now what is displacement? We just now we have defined. It is a shortest distance between initial and final positions of an object. You can write of an object, right? Secondly, second difference, we can say distance does not have any unique value. In this case, what is a unique value? Only one value. Okay, so not for any case, for a particular case it does not have any unique value, but displacement is having a unique value because it is a shortest distance. That is why, right? So shortest distance we can say is this displacement, so it is a having unique value. So we can write down first of all like this: it does not have any, it does not have any unique value. Second point over here we can write it has a unique value, right? Third point of difference is it is a scalar quantity. Scalar quantity and vector quantities we must be knowing. What is a scalar quantity? It is a quantity which is having magnitude, that means a numeric value, as well that means a numeric value only. Okay, and what is a vector quantity? The vector quantity is any physical quantity which is having any magnitude or numeric value as well as direction also specified. Here displacement is specifying some direction because it is going over here, it is affected by this movement. So displacement is having direction also. So what we can write, it is a scalar quantity. It is a vector quantity, right? Fourth point of difference. Fourthly, we can say the distance is always greater than or equal to displacement. This concept we can understand over here in this example. Distance is either equal to displacement or it is always greater than displacement, right? For the case of displacement, we can write, making a point that displacement is always either equal to or less than distance. So we can write like this: distance is always greater than or equal to displacement, right? For this we can write displacement always less than or equal to distance, because displacement is shortest, so it will always be either less than or it may be equal to distance, right? Now last and important point of difference is distance can have only positive values. It can never be negative, it can never be zero. Because it is direction dependent, it can have a negative value, it can have a zero value. We have understood over here, it can be zero, right? So we can write down, it is always positive and here we can write down, it can be positive, negative or zero. Or otherwise we can write down, it can be zero, it cannot be zero. Distance can never be zero, right? So for this we can write down, it cannot be zero. This I can write in place of this. Okay, so these are the differences that we have understood between distance and displacement, right? Next comes the concepts taken in numericals that I will discuss in our next video, right? The concepts related to distance and displacement, how these concepts are taken in numericals, that we will discuss in the next video. Hope you understood this lecture. If you have any queries, you can always ask. Thank you.